Hello students. Next let us look at how to get the network functions for a circuit which is of non-ladder type or a network which is of non-ladder type as we have drawn here. This is a resistive bridge T network. The name of the network is not important. Basically what it wants to show here is that it is not a ladder type network. There are many things that people do. One of the things is people try to make this into a ladder type network. That is one of the ways. How you can do that is we can basically take this as a delta network and do a star to delta conversion. When we do a star to delta conversion, as you can see, we will get a circuit which looks something like this. There will be a star instead of the delta, and then the original circuit will be there. So like that people sometimes try to do that, but that is a very long method. There is no need for us to do that. What we can do here is we can use simple KVL analysis to get the answer. See, what is important is whatever you do, all your relations should come in terms of V1, I1, V2, I3. Rest, whatever you are going to write here should not be taken in the final equation. That's the only thing. Every equation should be only in terms of V1, V2, I1, I2. So if I'm going to use KVL analysis, then I know that this one I will write it as I1 current. This one I can write it as I2 current in this direction, but since it is already drawn, since it is already drawn in this, so I will again write I2 in this direction. Now you might be asking, sir, if I2 is drawn in this direction, will not this equation be wrong? Because we have been taught that in mesh analysis the current should be taken in the same direction. See, taking current in the same direction is to follow a general convention. If you take it in the opposite direction, there is no issue. The only thing is that your final answer will have an I2 value which may be opposite to what is you might have got when you take it in the clockwise direction. It does not matter, but obviously we should always take care of the directions. Okay, now with the help of this, see, I took I2 clockwise, I3 also clockwise, but I2 was anti-clockwise because I already have I2 going in this direction. Okay, now how do we do it? So KVL analysis, KVL at mesh 1. So KVL at mesh 1 will give me what? So V1, so this is going to be, let me use a different color, let me use blue. Okay, so V1 and the current is going like this, so this is going to be plus minus, this is also going to be plus minus, so it is going to be V1 minus 1 I1 minus I3 minus 0.5 I1. See, I1 is going from top to bottom, I2 is also going from top to bottom, so it is plus I2. Why? Because I1 is also going like this, I2 is also going like this, so both of the currents are adding. If it was anti-clockwise, we would have taken a minus. Okay, that is the only difference. So you are having I1 plus I2. Now if I am going to rearrange this equation, I will get V1 is equal to I1. If I take the other side, then 1 and minus this, both of them will give me 1.5 I1. I2 minus, if I take it the other side, it becomes plus, so plus 0.5 I2, and I3, here it is plus 1 I3. If I take it the other side, it becomes minus 1 I3. So this is my first equation. Now look here, in this equation V1, I1, I2 are all okay. V1, I1, I2 are all okay because this is what is finally, I told you, we have to get all the equations in terms of V1, V2, I1, I2, isn't it? So out of that, only I3 is out of order. That we will have to take out somehow. That we'll see. Next, we will go for KVL at mesh 2. KVL at mesh 2. Now, KVL at mesh 2, again if I'm looking from here this side, so this is going to flow plus minus, this is going to be plus minus, correct? So this I will write it as V2 minus 1 time, now see I2 and I3 the direction are same, so I2 plus I3, then minus 0.5 I1 minus, not minus, plus I2. Why? Because they are in the same direction. Okay. So from here I can get V2 is equal to, now I1 terms minus 0.5, so if I take it the other side it becomes 0.5 I1, 0.5 I1, then I2, if I would see, here I am having I2, there is one here, there is another one here, so 1 and 0.5 I will get plus 1.5 I2, and I3 minus I3, if I take the other side I will get again plus, so it is going to be plus I3, that gives me equation 2. So now I have to get rid of I3. I3 is given in mesh 3, so let me first do that one also. So KVL at mesh 3. So mesh 3 is the top mesh from which I can get the value. So if I'm going to take, it's going to be plus minus, plus minus, plus minus. So if I'm going to take from back of the element, so plus 2 I3 plus 1 time I3 plus I2, that is for this one, this resistance, then plus 1 time I3 minus I1, so 1 times I3 minus I1 is equal to 0, from which I can rearrange. I will get, let me write I3 component, so this is going to be 4 I3, this is going to be 4 I3, and then we are going to have I3, I will write it there, no problem. First let me write I1 I2, so which is I1, so minus I1, I2 I am having only one, so plus I1, sorry I2 plus I2 plus 4 I3 is equal to 0. Okay, so this is my third one. So now I am having 3 equations. Now from here there can be 2 kinds of, up till here we do the same for most of the problems. From here we will have 2 kinds of method of solving this, based on if there is a element here attached here. If suppose there is some element attached here, then we will do it in a slightly different way. Okay, that I will explain little bit later, so let us keep that aside. Okay, and if suppose it is like this, then we know that, this is important here, we know that I2 is going to be taken as 0. We always take I2 is equal to 0 because no current is flowing there. If I2 is equal to 0, then what happens to these 3 equations? Because I2 is equal to 0, what I will do is I will write, therefore 1, 2 and 3 becomes 1, 2 and 3 becomes, first one equation V1 is equal to 1.5 I1, I2 becomes 0, so minus I3, that becomes equation number 4 now. Similarly, the second equation V2 is equal to 0.5 I1 plus I3. That is going to be my fifth equation. And the last equation is minus, let me write the 0 part first. 0 is equal to minus I1, I2 is 0 plus 4I3. That is going to be my sixth equation. Okay. Now, if such is the equation, I have made one mistake here. If that I2 is equal to 0, then I can't have these two. Sorry. Yeah. So only these two I can find out. Why? Because I2 is equal to 0. I had actually taken this problem from a case where there is a resistance in the second portal. So that I will do it later. Anyway, we can only find V2, V1 and V2 by I1 here. There is no other things that we can find out. There is no I2 thing we can find out. Maybe we can find out V1 by I1 also. Let me write that. We can find out even V1 by I1. Why? Because here I2 is going to be taken as 0. Okay. So if that is the case, then all I have to do is I have to substitute. See, here in fourth equation and fifth equation, I3 is what is not no. That is an extra term that we can get from 6. So from 6, we can say that I3 is equal to 1 by 4 I1. Correct? I3 is going to be 1 by 4 I1. Therefore, 4 becomes V1 is equal to 1.5 I1 and minus I3, I will put minus 1 by 4 I1. We know 1 by 3 can be written as 3 by 2. So let me write that as 3 by 2. 3 by 2 I1. From which I can write, therefore V1 is going to be 6 minus 1 divided by 4 I1, which becomes 5 by 4 I1. Okay. Therefore, V1 by I1 is going to be equal to 5 by 4. Since it is voltage by current, I will write 5 by 4 ohms. Correct? So V1 by I1 I have found out. Next is V2 by I1. For that I will look at equation fifth one. So from 5, from 5 I will get V2 is equal to 0.5, let me write as 1 by 2 I1 plus 3. So it is going to be plus 1 by 4 I1, which I will get 2 plus 3 divided by 4 I1, which is again 5 by 4 I1. Therefore, V2 by I1 is also going to be equal to 5 by 4 ohms. Again, voltage by current, so it is ohms. So that is how we will do it. Then last we have to find V2 by V1, correct? Last we have to find V2 by V1. So V2 by V1, how we can find out? We have found out just now that V1 by I1 is this. So let me write that as equation 7, and V2 by I1 is equation 8. Therefore, 7 V2 by V1, so 8 divided by 7, equation number 8 divided by equation number 7 will give me V2 by I1 divided by V1 by I1. It's going to be 5 by 4 by 5 by 4, which turns out to be V2 by V1 is 1. And since it's voltage by voltage, it is having no unit. So that is my third answer. So when you are not having any element connected here, what you have to assume is I2 is equal to 0. See, when I2 is equal to 0, there is no need to write this equation. You can directly do a KVL by considering I2 is equal to 0. Directly you consider that I2 is equal to 0, and then you do the KVL analysis of this, you will get the answer. There is no need to write these three, you will get totally different KVL equations, okay, when you consider I2 as equal to 0. But since here I am trying to do two types of questions here, that's why I have to write it in this form. Now let me do the second kind of problem. So you write two kinds of problem. The first problem was this one: for a bridge T network, find V2 by V1, V2 by I1, V1 by I1. That is what we have found here. Next one, we will put a resistor here. We will put a resistor here and we will say I2 is not going to be equal to. So let me draw that. Suppose there is a resistance here and that resistance is suppose 1 ohms. That resistance is suppose 1 ohm. In that case, mesh 1, it is going to be the same, there is no issue. Mesh 2, it is going to be slightly different because we are having 0.5. Now another 1 ohms we have added. So here the equation will be different. So let me rub this one so that I can write the equation properly now. For the second kind of problem, we can write, see, there is a resistance here. So this one will be plus minus. So plus minus 1 I2. So I will write plus I2 is equal to 0. Okay. From which I will get V2 is equal to, now minus 0.5 will go and become 0.5 I1, and then we will have for the case of I2 we will have minus 1 I2 and minus 0.5, so it is minus 0.5, just wait, yeah, this should have been minus. Sorry. Yeah, so 1 I2, 0.5 I2 minus 1 I2 will become minus 2.5 I2, which I take the other side becomes plus 2.5 I2, and I3 is plus I3. That is going to be equation 2, okay, and equation 3 is going to be same. And now we are having three equations like this. From here I will rub it off, and then I can solve this using a matrix method. So in matrix form I can write the equations as V1 V2 0 is going to be equal to 1.5 0.5 minus 1 0.5 2.5 1 minus 1 1 4, and then I1 I2 I3. So what we are trying to do is we are trying to solve to get the value of I1 and I2. Now I have written a matrix. Why can't I solve it using a calculator? We used to solve it using calculator, but here the problem is V1 and V2 are constants here. They are not a value. If it was a mathematical value, I could have very well solved these three simultaneous equations using calculator. But now that is not possible because we are having V1, V2 instead of some mathematical value. So what I will have to do here is I will have to do the matrix method for finding out I1 and I2. I will only try to do I1 and I2. Okay, so what is I1? I1 is going to be delta 1 divided by delta 1 divided by delta, which you all can see delta 1 is going to be replacing the first one with V1 V2 0. The rest remains same, 0.5 2.5 1 minus 1 1 4 divided by delta. Delta is what? The whole matrix, which is 1.5 0.5 minus 1, 0.5, 2.5, 1, minus 1, 1, 4. If you would solve this matrix, there is one small mistake that I have done here. Since it is V2, V2 was not there, so this I will write it as 0. Sorry. Okay, I forgot in that mesh, second mesh. So based on that, this one is also going to be equal to 0. Okay, so now it is going to be V1 multiplied with 2.5 into 4 minus 1. Then it is going to be minus 0.5 into 0 minus 0. Same way, minus 1 minus, minus 1, 0 minus 0. And now in the bottom, if you would do it, you can try to solve it, you will get the answer as 9. Okay, you can try it on your own, you will get the answer as 9. So this equation, therefore, I can say I1 becomes, from this one 2.5 4 times is going to be 10, 10 minus 1 is 9, so it is 9V1 divided by 9, which comes out to be V1. Therefore, I1 is equal to V1. This is the fourth equation that we have got. Similarly, if I am going to do I2, which is delta 2 by delta, I will get, in the second column I will have to change. So 1.5, 0.5, minus 1. The second column is going to be V1, 0, 0. The third column is going to be minus 1, 1, 4. And delta we have already calculated it as 9. From this one I will get 1.5, 0 minus 0. Second is minus V1, 0.5 into 4 plus 1. The last one is minus 1, 0 minus 0 divided by 9. Therefore, I will get I2 is going to be equal to 2 plus 1 is 3, so minus 3V1 divided by 9, which comes out to be minus V1 divided by 3. Minus V1 divided by 3. So now based on these two, I can find out many values, because after I have put here the resistor, I can say that V2 is going to be equal to minus of 1 into I2. So minus of I2. So this equation is also there. V2 is equal to minus 1 I2. Okay. So based on these three equations, now what does the question say? Let me write the initial question. V2 by V1, V2 by I1, I2 by V1, and finally I2 by I1. I2 by I1. Correct? So let us do one by one. First is V2 by V1. What is V1 here? V1 from here, this is fifth equation. Therefore, I can say V1 is equal to minus 3 times I1. Correct? So first I have to find V2 by V1. Correct? This is what I want to find out. So V1 in terms of I1 is already given here. Let me write this as equation number 6. V2 I have written somewhere. Yeah, V2 is written in terms of I2 here. So I want to written in terms of this is I2. Yeah. Therefore, V2, let me name this equation as equation number 7. Equation number 7. Okay. So if I want to find V2 by V1, I will divide equation number 7 with equation number 6. So what is equation number 7? Equation number 7 is V2 is equal to minus I2, which I got from here. Okay. And divided by V1 is equal to minus 3I2, from which I will get V2 by V1 is going to be equal to minus 1 by minus 3, which is 1 by 3. So I have got V2 by V1. Next I have to find V2 by I1. So V2 by I1. How do I get V2 by I1? How do I get V2 by I1? Let me do it in another page. So how do I get V2 by I1? Okay, so for V2 by I1, let me look. V2 is in terms of I2, so I1 in terms of I2, is there any way? Yeah, if you look at 4 and 6, from 4 and 6 I can say I1 and I2 there is a relation. So I can say from 4 and 6, from 4 and 6, what do you see? V1, isn't it? So I1 is equal to minus 3I2. So I1 is equal to minus 3I2. Therefore, from 7, we had V2 is equal to minus I2. Therefore, V2 is equal to, if I substitute I2 from here, it is going to be minus I1 by 3. Correct? So minus I1 by 3, which comes out to be I1 by 3. Therefore, V2 by I1 is going to be equal to V2 by I1 is going to be equal to 1 by 3 ohms. So that also we have found out. What is the last one? So sorry, I2 by V1. What is I2 by V1? So next is I2 by V1. I2 by V1. Now we have already found out that V1 is equal to I1. In which equation? Previously we have just now found out. Equation number 4. From equation 4. This was equation 4. Now here, if I am going to substitute I2 from here, then I will get, therefore, from this, let me write as equation 8. Okay, from 8 I can say V1 is equal to this one. Instead of I1 I will substitute minus 3I2. So therefore V1 by I2 is going to be equal to minus 3 again ohms, because it is V1 by I2. Therefore I can write I2 by V1 to be minus 1 by 3 mho. Okay, because it is inverse of resistance, so it is mho. So this is the third one I have to find out, that I have found out. What is the last one? I2 by I1, which I have already done from 8. So I2 by I1, if I want to find out from 8, I can find out I2 by I1 is equal to minus of 1 by 3. So I have found out. So I have shown two problems, how to do two problems. One is when you are having an ending with a resistance, and the first one was when you didn't have a resistance. Then what you have to do. So both these problems I have solved it here. I will give you for the worksheet also, I will give you a similar problem wherein in one there will be a impedance at the end, and the second one there will be no impedance at the end. Okay, thank you.